Hi all, Patty here. Today we're covering the basics of C# Part 1. This is the first video of a multi-part series focusing on an introduction level overview of C#'s language features and how to use them. So we're going to go through a number of things. My previous video was about the .NET Core runtime and a number of the .NET Core pieces. This is actually getting into the C# language, the specifics of that, and how to use each language feature within C#. And there will be a number of these videos, kind of going from the most basic pieces to more advanced pieces. And we'll kind of build simple applications as we go. And we'll build more complicated applications later on in this video series. We'll start with numbers today, and then we'll use basic math in C#. After that, we'll talk about strings and some of the C# specific behavior around them. Finally, today we're going to build a Hello World application so you can see the beginnings of a working C# program. With that out of the way, let's get to it. Numbers and basic math. Let's go. All right, so the first thing we'll talk about is integer types. These are whole numbers that appear within C#. They're specific numerical types that you'll be using a lot. These first two ones are the most common. So the first one is integer. We'll talk about integer first. This is system.int32. It's called this because it's a 32-bit number, and it ranges from -2 billion to +2 billion, roughly. There's an exact number in there, and you'll see here, if you assign it to 0, it covers a negative and positive number range. And we'll talk about that in a second with the next set of numbers. Int is for smaller numbers. Again, 2 billion to -2 billion to +2 billion is a pretty big range, but there's also the long, which is a much, much bigger range. I don't even know how to say this number, but it's a pretty big number, and you'll probably never really need long, only in very specific scenarios where the numbers are going to get very large. So longs will hold much bigger numbers, ints will hold smaller numbers on both the negative and positive side. I reference that because there are some times when you know you'll never need a negative number, and you'll want to use it in an unsigned integer or an unsigned long. Now, these two types are, again, integer types, but never contain a negative number. And in fact, if I put a negative number in here, the compiler will complain and indicate that you can't actually convert a -1 to an unsigned integer. This can only contain 0 to its max number. The actual range doubles in terms of the positive range because we get rid of the negative storage, and then this gets to the space that this would store for an integer gets to be added to this positive area. So it kind of helps with that. And unsigned and longs will be able to hold a much larger positive number than a regular long could. So this does expand your options. If you never expect to see a negative number, you'll sometimes see these being used. But in most cases, programmers and engineers will generally still just use integer and long in most cases, unless there's some edge case or specific reason why they really wanted to use a uint or a ulong. The other four types of integers are the same and similar. They're just that they are smaller. So there's byte, which is an unsigned integer that's smaller. And then there's sbyte, which is like an integer, but just on the negative side as well. These ranges hold just 256 numbers, 256 possibilities within the byte, and then it's just whether you want it to be negative or whether you want it to be just positive. Again, this will use less memory than an integer or a long, but it'll give you a much smaller range, and you'll be much more likely to kind of go outside of these bounds. And these are not used as often as just using an integer as a long. Most computers have a ton of extra memory, so you're not usually operating in a space where using these smaller numbers is absolutely necessary. And there's no real reason to use them unless you're just trying to save space within memory and really optimizing specifically just for memory consumption within a machine. The other two are the same. They're just slightly larger. They're 30,000, 32,000, roughly around 65,000 possible opportunities. You'll see them sometimes. Especially, like I said, within systems, if you're in IoT or you're working on edge devices or cell phones or things like that, you might want to use some of these types if you're storing a large number of values and you just want to keep the memory consumption as small as possible. You may want to use these smaller number types if you don't expect to have a big number that an integer or long really actually needs. So next, we'll talk about floating point types. These are decimals, or basically numbers with decimal places in them. And there's actually three different types for C#. There's the float, which is the first type. It's a 32-bit size. It has 7-digit precision, so it's actually the smallest footprint for a decimal type of numbers. And it has the least amount of precision, but the least amount of memory footprint. So again, when you're saving memory, you might want to use this. It's worth keeping in mind that you have to use an F with floating with the float. specifically as a type. Otherwise, you won't be able to convert it, or it'll try to convert it and cast it, and you don't want that. So if you want a float specifically, you have to use the F. The next type of floating type is called double. This is the default type whenever you create a decimal type. So if you put in 3.5 as a number, it'll always store it as a double, as you can see here. You can see that the compiler tells you this is being stored as a double, so it doesn't require the D. You can use a lowercase or an uppercase F or D. In this case, you can use a D, or you can use a lowercase f as an example in here. It doesn't matter which one you do, but the D for doubles is not required. The compiler actually does a double by default. Typically, when you're dealing with decimal place numbers, you'll just get a double by default. You don't have to do any extra letters unless you want to have the smaller memory footprint or the much larger memory footprint, much larger numbers and higher precision, which is the last type called decimal and system.decimal. You have to use an M within decimal to have the higher precision and the larger footprint size. You can see in here it stores this as a decimal, and it's certainly happy to do so. If you do decimal number again with the 3.5 here, like you'll see that this gets stored as a double, and then as soon as I change it to an M, it actually knows what I'm talking about, and it actually stores it here as a decimal. The same thing with the floating number. This will do the same thing. If I put it in as 3.5, you can see it defaults to double, but as soon as I put in an F, it'll know automatically that I mean that a float specifically, and then this number will then be considered a float, and if I try to treat it or use anything with it, it'll automatically know I'm trying to use it as a float type. So again, there's 3 different floating point types. There's the smallest footprint with the least precision, kind of the middle ground, which is the default, which is double, system.double, and then decimal places like the largest with the most accurate, most highest precision. And this is important when you're doing lots of calculations and you want the decimal place calculations accurate out to the farthest decimal places. You may need decimal in those calculations, but again, pretty much always will want to use a double in most use cases. This is when you're dealing with dollars and cents and currency and any kind of small, just average run-of-the-mill daily numbers. You'll definitely just want to use double and stick to that. One additional note about floating point types is the default is a double just because it's a good balance between memory footprint, which is 64 bits, and then the number of precision is out to 14 or 15 digits, which is pretty good, and it's a good balance between how much memory you're consuming on a system and then how accurate it is out to 14, 15 points within the decimal places. It's a pretty good balance. You really only need to go to float or decimals when you really specifically need them. Just stick with doubles. You'll usually be okay unless you're on an edge case, and you'll probably encounter those fairly rarely. Next, we'll talk about some basic mathematics that you'll be doing with numbers. I've picked some very basic numbers here. They're just going to deal with integers to start, and we'll get into how these kind of convert into other types as we go along. The very first thing we'll do is we'll talk about subtraction. Obviously, you can subtract 1 from 1. The result here is 0. You can also add here, which is 1 plus 1. You'll see the syntax. You just do minus and plus. This is pretty straightforward stuff. One of the great things about C# is it also gives you access to some other fairly convenient operators. So as an example, we can go number one plus plus here, like this. What's going to happen is number 1 will be incremented. So this basically makes number 1 go up by 1 number, and so now number 1 is 2. I can prove that by doing call to that right line number 1 and running this program, and it'll actually show you that number 1 will show as 2, like that. So within that, you see that this plus plus is called an increment. Number also has a decrement, which is perfect for reducing just by 1 number, and we'll run this and show you exactly as well. So in this particular case, we've incremented it by 1, then we've decremented it, and it's back to its original value. One of the other options is you can do multiplication. So you can say var number 3 is equal to 5, and then you can do number 1. Let's do var number 4 is equal to 2, and then you can say var multiplication result is number 3, and then we do a star or asterisk for multiplication. And this one will be actually a perfect example of the result of this will be 10, of course. So we'll go ahead and run this. We'll comment this out so we don't have to really worry about it. And you'll see here that we come out with 10, which is a nice round number. You'll also see the compiler already knows that you're multiplying a whole number or integer by another whole number or integer. And we'll talk about this because if you do multiply it by another floating point number, it'll automatically start converting it to decimal places. So if I do var number 5 and I say 2.00, this obviously becomes number 5 becomes a slightly different thing. So this causes the compiler to convert this into a double. And this will convert your integer into, essentially it does the integer times a double, and the result is a double, which causes it to convert that value into a double value, which is okay. It's not that big of a deal. It still comes out to being 10. But now the type, when you look at it, is actually a double type. Which you'll see if you're going to go casting and comparing to other types, you'll want to be aware that multiplying a whole or integer number, long, int, ulong, all these types against a double or a floating point type will convert the result into a floating point type as well. It's just worth keeping that in mind. Other than multiplication, you also get division. Let's just do this as well. Var number 7 into 5. Division result is equal to number 6 divided by number 7. And then we're going to go ahead and print this out. And we'll see what that actually comes out with. So we'll go ahead and run this. You'll actually see this prints out 2 for the result. So 10 divided by 5 will be 2. You'd use this little slash for division. You can also do something called compound assignment. Compound assignment is when you do a mathematical operation and you assign the result back to the numbers. So if I do number 1 plus equals 25 like this, and then we want to print number 1, and otherwise we haven't changed it, we'll actually comment these out so that we're not modifying this in any way, shape, or form. What happens is we add 25 and we assign the result back to the original value. So this plus equals does that. Then you can do the same thing to minus equals, and actually any operator can do this. So you can run a compound assignment on any operator plus the equals sign. It'll assign the resulting value back to the variable on the left side of the operand, and that'll print out back to the original number, back to 1. So we'll go ahead and comment this back out, and we'll talk about remainder. So remainder is basically that takes the number on the left side, it takes the first number, and then it divides by the second and returns the remainder. So if we do, as an example, 5, and then a percentage sign, and then 4, the result here is 1. So we'll go ahead and print the remainder. It does 5 divided by 4, which goes in one time, and then it produces the remainder. So this will produce 1 as a remainder. If we do 6, as an example, we'll now have 2. So this is actually printing out the remainder. It goes into it once, obviously, as division, and then it'll print out the remainder when you do this percent sign. So next we'll talk about raising numbers to a power. This is another pretty common one. So you'll do math.pow. This is the most popular thing that you'll do. And this one expects actually doubles on both sides, but you can still put in an integer and cast it if you really need to. Let's do 2 to the power of 3. And this is obviously going to result in 8. Var power equals this. We're going to go ahead and do console.writeLine power. Like that. And this actually is going to be 8. You'll see that here. It'll print it out like that. This will be the most common math method that you'll use, but the math actually has a whole bunch of them. If you go into this class, you'll see that math has a ton of options in terms of what you can actually do with math. And you'll come across some of these: sine, round, square root, a lot of these, tan. Some of these will be very common. Some of them will be less common. It's just a matter of like what kind of work you're doing and what kind of solutions or problems you're solving, how much of the math you'll use. I'm not a mathematician. I make use of the math methods all the time. I don't usually work in a lot of mathematics. If you're in mathematics, you'll use the math class a bit more. You probably even will extend it to include more common stuff that you'll be doing within mathematics. But it already includes some of the basics and the easy ones you'll see, for example, on a calculator. So next, we'll talk about strings. Strings are how C# stores text, and we'll talk about how we can manipulate and use text to our advantage, and a couple of the useful things within C# that you can do with strings. Some important things that you'll need to know: strings are immutable. Immutable means that the string is not modifiable or editable once you create it. Another way to say it is that it's read-only. If you do modify a string, what happens is this original string gets destroyed and recreated. And this is really important to know because if you are looping over or iterating over top of a string and modifying it a lot, you'll just need to know that performance overhead can be significant in that case, especially if you're doing it hundreds or thousands of times. For example, when you're producing a document or a text file, that you won't want to use strings in a raw format. And we'll show you a way as an example to get past that. What you'll use to get around that is called String Builder. String Builder is a specific class designed to help you build strings without having to destroy it and recreate it. It stores it in the background, not in an immutable format, but instead storing it in a way that will allow you to performantly modify and edit the string as you go along. And you can append and edit this as you go, however you see fit. You can build the string as you go with String Builder, and you can do build append line like this. And you'll do test line, and then you can do console.write line. And what you'll want to do is, what you want to do is you'll do a var like output equals builder.toString like this. So what this does is it converts the stored memory version of the string into an actual string, and then the output is immutable. So this is read only. You don't want to edit this. If you need to edit the string any further, you use the builder, and then you'll do another output as an example. But this output can be printed, and you'll print it just like this, and it'll print it out just for you like that. Test line. If you need to modify or edit this, you can do builder.append line, and you can do test line 2 like this. And again, as I mentioned, you can iterate over this and add a bunch of lines to this. This is important when you're building log entries or log events, or you're, like I said, building a document with lots of text. Rather than adding and appending to an actual string, as an example like this, if I do test line like this, let's do like just var actual. Let's just do var actual string like this. And then you can do actual string. You can do actual string and then plus. And again, you can do additive operators with string, which is really interesting. You can do test line 2. This will actually destroy the original string and create a new string in its place. And I also need to do /n, I believe, to add a new line like this. I think I actually need to do a /n like that, but let's test it. Let's see. Just like that. And there's actually, I don't need a space here, but you can do an add. You can do add like this to add this text to it. But in this particular case, it doesn't just add this into the string. It actually destroys the original, copies the original content into the a new copy of the string, and prints that out. So as you can probably imagine, multiplying this by thousands or millions of times would be very, very expensive. So just depending on how many operations you plan on doing in a particular string, you may want to use String Builder to improve that performance. Some cases it's not actually necessary. If you're just going to make a few edits or you're just going to, append a line or two, it's probably not a big deal. But anytime you want to do like large scale operations on a string, you'll want to convert it into a String Builder and then make the modifications there. One of the options is if you're going to do a lot of operations on a string, you can actually do var builder 2 is new string builder, and you can actually pass into it a string. So you can actually do actual string like this, and it'll build the string builder for you to start doing a bunch of operations on. And then you can do builder2 output equals builder2.toString once you're done with your operations. And you'll see that that's a more performant way to do it. Even when you're either starting with nothing, like in this first case, or you're starting from a string and you want to do a lot of operations, you can do it the second way as well and create the string builder from a string that you already have. The next thing we want to talk about is something called string interpolation. String interpolation is when you insert values that you're storing into the middle of a particular string. So let's just say, for example, I have var number equals 500, and I want to print out, for example, that there's going to be 500 villagers. Let's just say. So let's do var output, and I already have an output, so I'm going to comment this out so I don't have a problem. And the way to do this is with a $sign, and a $sign indicates that you're going to have interpolation or allows interpolation within a string. And this is how you'll do it. So the villager count, and then you do braces. So you do an opening brace to open, and then you can put any values in here that you want. and it will automatically build this into the string exactly as is. So you don't have to do these spaces. It's really up to you whether you have spaces. For formatting, I like to have spaces, but it's worth keeping in mind that these spaces get eliminated. The inside the brackets spaces get eliminated, and outside the braces, the spaces are kept. So once the brace is created, basically this entire block is replaced like this. So we'll go ahead and do a print out of this just so you can see what this looks like. Just like that, villager count is 500. And if I'll show you if I add spaces in here, it doesn't matter. If I add spaces here like this, it won't matter. Just to demonstrate that that doesn't have any impact. And then if I go to the inside of the brace or the outside of the braces like that and add a bunch of spaces, it will actually keep this up to the brace. So just worth keeping in mind. The other thing that you'll see most common is a verbatim identifier is an @. This turns it into a string literal, and it'll actually take exactly what's inside of here and use that. So there's and you saw in an earlier example where I use /n. The /n will actually appear in the string itself. It'll take it as a string literal, rather than as a new line indicator. It'll actually take it literally. And once you've added this @ sign like this, you can actually add new lines within the string itself. So I can just do new lines just by using enter, just like this. If I actually take out the @ this isn't actually allowed. So without the @ these new lines are interpreted within the code, and all of the string has to be written on the same line. Once I add the @ it actually allows me to do new lines within it, and it'll let me print this out. So it'll look just like this with the new lines. The only problem with this really is that the indentations definitely look a little bit strange. If I add in the tabs like this, it literally adds the tabs into the string. So you'll see a bunch of the tabs like this. So you'll see the indentation within the editor looks maybe a little bit funky, but you don't want to tab it out in this particular case because the tabs actually will appear in the actual string. This can be kind of a pro and a con. If you're writing a lot of text, the verbatim can help a lot. You can keep everything on one string or one line, and this verbatim will actually help you eliminate a lot of these like /n and some of the other kind of artifacts you'll find with strings. We don't really want that. You actually want exactly what's within the string that you put, and it'll come out as an output. These are usually combines, and actually recently within C#8 they made it so that you can do it in any order. But for all code that was written prior to C#8, you had to do @ first and then the $sign after. So from here, we're going to go ahead and build a basic Hello World application. We'll do console.writeLine. You actually start with this, which is Hello World like this. I think that the basic project starts with something like this. When I go ahead and run this, what it'll do is it'll do Hello World. Hi. Welcome to the world, C#. We're going to do it a little bit more complex than that. We're going to do var name, and we're going to go ahead and put in our name. And in my particular case, I'm going to put in Padgy, because that's my name. And we're going to do some of the things that we learned today. So within console.writeLine, we're actually going to do verbatim. We're actually going to do a verbatim string, and we're going to do hello world, and we're going to do my name is Padgy. No, I'm going to do Padgy. Okay, so that's one way to do it. I can hard code it into the string like this. That's one way to do it. If I don't want to do that, I'm just going to do name like so. This allows me to put in a variable into the string, and I can put in anything that I want as a name. So I can put in hello world. It appears exactly the same as it did before when it was hard-coded, except this time it's now using the variable that I've put in with string interpolation. Now, obviously, I can put in var name2 equals not Padgy, for example, and I can switch this out to name2 instead. And in this particular case, it'll put in not Padgy. So this is an example of string interpolation, exactly as we already learned today, and shows how to build a basic console application for Hello World. One of the other options that we can do is we can do something like, one of the other things that we learned today is related to string builders, and we'll just do this, name2. And we'll do builder dot append line like this. And we'll just do, I'm definitely not an imposter. like that. And then what we'll do is we'll actually add this in. And we'll do, what do we do? We'll do, let's actually start with a blank. Let's start with a blank string builder like this. And then we'll do, you can do string interpolations with complex operations as well. So we'll do builder.toString like this. And this will actually be, this will be perfectly fine. So this is actually warning you that you don't actually have to do this. I think it's giving you a tip that it's you can simplify the interpolation. What's happening here is that when you do string interpolation, it'll automatically set anything that isn't already a string. It'll run the toString method on it automatically. And so when I run this, you'll see that the builder gets converted to a string using its toString method. And the same thing happens with integers and numbers and other complex types. Doing in string interpolation with a complex object will automatically call its toString method. So you don't have to call toString. You can do other operations like we did earlier, which is things like 2 plus 10 within the string interpolation. So this shows some operations being done kind of within here where you get a number printed out. You can also do things, you know, like whatever you want. You can do 2 times 10 divided by 5. You can do kind of whatever other complex things that you want. You can even call other methods and other things. So if I were to write a simple method like static int multiply, you take int first, int second, like this, and then you do return first times seconds, and then you can actually call this method from within the string interpolation, and it'll do everything for you. So 2 times 5 like that. And it'll call the method, and then it'll convert it to string automatically for you. We'll go ahead and run that, and you'll see it multiplies and prints out the result into the console. So this is a Hello World application. It's a little bit more complex, showing some of the things that we learned today, including some of the math, some of the numbers, and string interpolation, as well as kind of a basic Hello World application. And with that, that's everything for today. Well, that's it for today. Thank you very much for watching. If you enjoyed this video, please like, share, and subscribe, and I'll see you again soon.